Hello everyone, welcome to my YouTube channel School of Chemistry. Today we are going to study about the relationship between Cp and Cv. Cp and Cv, as I told you in my previous video, that molar heat capacity at constant pressure and molar heat capacity at constant volume. Okay, so according to first law of thermodynamics, first law of thermodynamics, we can write that the internal energy change, that is du, is equal to the small energy supplied in the form of heat minus pdv. Okay, rearranging the equation, can we write the heat supplied to system is equal to du plus pdv. Now, as we know that heat capacity or molar heat capacity is given as heat supplied to system by change in temperature. So can we write C is equal to delta Q by dt, which can be further written as du plus pdv upon dt. Okay, if the process is carried out at constant volume, can we write Cv, which is equal to du upon dt at constant volume plus pdv by dt, and this term, the second term, will be equal to 0, as dv is equal to 0, because it is kept constant. So if volume is kept constant, dv is equal to 0, so this second term becomes 0, pdv upon dt. So the molar heat capacity at constant volume can be written as the change in internal energy change du upon dt at constant volume. Let it be as equation number 1. Now if we carry out the same process at constant pressure, if the process is carried out at constant pressure, it can be written as Cp is equal to du by dt at constant pressure plus pressure is constant dv by dt, that is change in volume with change in temperature. Now as we know, let it be as equation number 2. Now as we know that enthalpy is given as H is equal to U plus PV. Now differentiating the equation, with respect to temperature. So we can write dH by dt is equal to du by dt plus pressure constant dv by dt. Okay, and this become equation number 3. Equating equation 2 and equation 3, equation number 2 and 3. So can we write Cp is equal to dH by dt at constant pressure. Now for an ideal gas, the term pressure can be dropped and we can directly write Cp is equal to dH by dt. This can also be written for an ideal gas. Now as we know that Cp is always greater than Cv as the heat supplied to a system at constant pressure that involves a slight expansion in the volume of the system, and if there is slight expansion in the system, then the heat is used up in two processes. One is increasing the volume and the second is in increasing the temperature of the system. Whereas in case of constant volume, the heat is only used to increase the internal energy or directly the temperature of the system. That's why in case of constant pressure, we need to supply greater amount of heat as compared to at constant volume. So we can write the enthalpy expression as H is equal to U plus PV, and for 1 mole of an ideal gas, PV is equal to RT as the number of moles is equal to 1. So can we substitute PV in the above equation with RT? So we can write H is equal to U plus RT. Now differentiating the above equation with respect to temperature, the above equation with respect to temperature. So we write dH by dt is equal to du by dt plus R, as dt by dt gets cancelled out. So we are only left with the gas constant, that is R. Now dH by dt minus du by dt is equal to R. So we can substitute this as Cp minus Cv is equal to R. So this is the relation between the molar heat capacity at constant volume and the molar heat capacity at constant pressure. Hope my videos are helping you in your studies. So for more interesting videos, please like and subscribe to my YouTube channel, School of Chemistry. Thank you.